TypeScript is a free and open-source high-level programming language developed by Microsoft that adds static typing with optional type annotations to JavaScript. It is designed for the development of large applications and transpiles to JavaScript. Because TypeScript is a superset of JavaScript, all JavaScript programs are syntactically valid TypeScript, but they can fail to type check for safety reasons. TypeScript may be used to develop JavaScript applications for both client-side and server-side execution, as with Node.js, Deno or Bun. Multiple options are available for transpilation. The default TypeScript compiler can be used, or the Babel compiler can be invoked to convert TypeScript to JavaScript. TypeScript supports definition files that can contain type information of existing JavaScript libraries, much like C++ header files can describe the structure of existing object files. This enables other programs to use the values defined in the files as if they were statically typed TypeScript entities. There are third-party header files for popular libraries such as jQuery, MongoDB, and D3.js. TypeScript headers for the Node.js library modules are also available, allowing development of Node.js programs within TypeScript. The TypeScript compiler is itself written in TypeScript and compiled to JavaScript. It is licensed under the Apache License 2.0. Anders Heilsberg, lead architect of C# and creator of Delphi and Turbo Pascal, has worked on the development of TypeScript. History TypeScript was released to the public in October 2012, with version 0.8, after 2 years of internal development at Microsoft. Soon after the initial public release, Miguel de Icaza praised the language itself, but criticized the lack of mature IDE support apart from Microsoft Visual Studio, which was not available on Linux and macOS at the time. As of April 2021, there is support in other IDEs and text editors, including Emacs, Vim, WebStorm, Atom and Microsoft's own Visual Studio Code. TypeScript 0.9, released in 2013, added support for generics. TypeScript 1.0 was released at Microsoft's Build Developer Conference in 2014. Visual Studio 2013 Update 2 provided built-in support for TypeScript. Further improvements were made in July 2014, when the development team announced a new TypeScript compiler, asserted to have a 5-fold performance increase. Simultaneously, the source code, which was initially hosted on Codeplex, was moved to GitHub. On the 22nd of September 2016, TypeScript 2.0 was released, introducing several features, including the ability for programmers to optionally enforce null safety, to mitigate what's sometimes referred to as the billion-dollar mistake. TypeScript 3.0 was released on the 30th of July 2018, bringing many language additions like tuples and REST parameters and spread expressions, REST parameters with tuple types, generic REST parameters and so on. TypeScript 4.0 was released on the 20th of August 2020. While 4.0 did not introduce any breaking changes, it added language features such as custom JSX factories and variadic tuple types. TypeScript 5.0 was released on the 16th of March 2023 and included support for decorators. Design TypeScript originated from the shortcomings of JavaScript for the development of large-scale applications both at Microsoft and among their external customers. Challenges with dealing with complex JavaScript code led to demand for custom tooling to ease developing of components in the language. Developers sought a solution that would not break compatibility with the ECMAScript standard and its ecosystem, so a compiler was developed to transform a superset of JavaScript with type annotations and classes, TypeScript files, back into vanilla ECMAScript 5 code. TypeScript classes were based on the then-proposed ECMAScript 6 class specification to make writing prototypal inheritance less verbose and error-prone, and type annotations enabled IntelliSense and improved tooling. Features TypeScript adds the following syntax extensions to JavaScript: type annotations and compile time, type checking, type inference interfaces, enumerated types, generics, namespaces, tuples, explicit resource management. Syntactically, TypeScript is very similar to JavaScript. Net, Another Microsoft implementation of the ECMA 262 language standard that added support for static typing and classical object-oriented language features such as classes, inheritance, interfaces, and namespaces. Other inspirations include Java and C#. Type annotations. TypeScript provides static typing through type annotations to enable type checking at compile time. Primitive types are annotated using all lowercase types, such as number, boolean, bigint, and string. These types are distinct from their boxed counterparts, number, boolean, etc., which cannot have operations performed from values directly. A number and number cannot be added. There are additionally undefined and null types for their respective values. All other non-primitive types are annotated using their class name, such as error. Arrays can be written in two different ways which are both syntactically the same: the generic-based syntax array and a shorthand with T. Additional built-in data types are tuples, unions, never in any. An array with predefined data types at each index is a tuple, represented as type 1, type 2, type n. A variable that can hold more than one type of data is a union, represented using the logical OR, symbol, string, number. The never type is used when a given type should be impossible to create, which is useful for filtering mapped types. A value of type any supports the same operations as a value in JavaScript, and minimal static type checking is performed, which makes it suitable for weakly or dynamically typed structures. This is generally discouraged practice and should be avoided when possible. Type annotations can be exported to a separate declarations file to make type information available for TypeScript scripts using types already compiled into JavaScript. Annotations can be declared for an existing JavaScript library, as has been done for Node.js and jQuery. The TypeScript compiler makes use of type inference when types are not given. For example, the add method in the code above would be inferred as returning a number even if no return type annotation had been provided. This is based on the static types of left and right being numbers, and the compiler's knowledge that the result of adding two numbers is always a number. If no type can be inferred because of lack of declarations, such as in a JavaScript module without types, then it defaults to the dynamic any type. Additional module types can be provided using a TS declaration file using the declare module, module name, syntax. Declaration files. When a TypeScript script gets compiled, there is an option to generate a declaration file, with the extension TS, that functions as an interface to the components in the compiled JavaScript. In the process, the compiler strips away all function and method bodies and preserves only the signatures of the types that are exported. The resulting declaration file can then be used to describe the exported virtual TypeScript types of a JavaScript library or module when a third-party developer consumes it from TypeScript. The concept of declaration files is analogous to the concept of header files found in C, C++. Generics. Main article. Generic programming. TypeScript supports generic programming using a syntax similar to Java. The following is an example of the identity function. Classes. TypeScript uses the same annotation style for class methods and fields as for functions and variables respectively. Compared with vanilla JavaScript classes, a TypeScript class can also implement an interface through the implements keyword, use generic parameters similarly to Java, and specify public and private fields. Union types. This section is an excerpt from Union type section. TypeScript. Union types are supported in TypeScript. The values are implicitly tagged with a type by the language, and may be retrieved using a type of call for primitive values and an instance of comparison for complex data types. Types with overlapping usage, e.g. a slice method exists on both strings and arrays. The plus operator works on both strings and numbers. Don't need additional narrowing to use these features. Enumerated types. This section is an excerpt from enumerated type section. TypeScript. TypeScript adds an enum data type to JavaScript. Modules and namespaces. TypeScript distinguishes between modules and namespaces. Both features in TypeScript support encapsulation of classes, interfaces, functions and variables into containers. Namespaces, formerly internal modules, utilize JavaScript immediately invoked function expressions to encapsulate code, whereas modules, formerly external modules, use existing JavaScript library patterns, common JS or ES modules. Compatibility with JavaScript as TypeScript is simply a superset of JavaScript. Existing JavaScript can be quickly adapted to TypeScript and TypeScript program can seamlessly consume JavaScript. The compiler can target all ECMAScript versions 5 and above, transpiling modern features like classes and arrow functions to their older counterparts. With TypeScript, it is possible to use existing JavaScript code, incorporate popular JavaScript libraries, and call TypeScript-generated code from other JavaScript. Type declarations for these libraries are usually provided with the source code but can be declared or installed separately if needed. For the typed instance analogous to a handwritten document, see manuscript. TypeScript.